Today we're going to be talking about function basics. So in your notes, you're going to write the domain comes from the x values. The range comes from the y values. X values are found in the first in a coordinate, to the right or left on a graph. A graph is discrete if it contains just points, but continuous if you can draw a line without lifting your pencil. Okay? So I want to talk to you first about the x values here. So the x values are found first in a coordinate. So basically, if we had, remember from Algebra 1, we had x, comma, y. So the x value is what's found first. So we're going to talk to you about function notation. You're going to see f of x, and it is pronounced f of x. And if you take a look here, this is the notation you should get used to seeing. F of x is also known as y. When you were in Algebra 1, we used to always say y equals mx plus b. Now in Algebra 2, we're going to talk about it as function notation. So the first letter names the function. And the second letter identifies the variable inside the function. So this function is f with x's in it. So let's take a look at what we're given. We're given a function, and the function is 3x squared minus 2x minus 4. So the directions say evaluate. So what we are going to do in this function, where we see we're working with x's, here's an x, here's an x, and here is an x. What we're going to do is everywhere we see an x, we're going to open up parentheses, and guess what? We are going to drop into the parentheses. We're going to drop in a 0. Well, the question is, where did that 0 come from? Well, whatever is here, we drop it into the parentheses. So we replace the first x with 0, and we replace the second x with 0. Okay? All right. So here we go. When we do that and we evaluate, we say 3 times 0 squared, which is 0, minus 2 times 0, which is 0, minus 4. So the final answer is negative 4. Let's take a look at number 2. F of negative 2. What does this mean? This means the function's name is f, and everywhere we see an x, we're going to drop in a negative 2. So we're going to open up parentheses. Here are our parentheses. So everywhere there was an x, we're going to put in the value here, which is negative 2. We're going to simplify. Simplify, we use the order of operations. And so here we're going to do negative 2 squared, which is 4. 4 times 3 is 12. So this is 12. Here we're going to do minus 2 times negative 2. So what is that going to be? Plus 4. And then we have minus 4 at the end. We simplify, and voila, we get 12. So f of negative 2 is 12. Well, what is this w here for? Well, let's go back to what we know. The function is f. So we're going to write down f again, and everywhere we see parentheses, or everywhere we see an x in our regular function, we're going to open up parentheses. So we have 3x squared minus 2x minus 4. So what we're going to do in those places, we are going to drop in a what? You got it. We're going to drop in a w. So this becomes 3w squared minus 2w minus 4. No like terms, so we can't go on any further. Well, the next one, excuse the bell, sorry. The next one is f of w plus 1. Well, what is the name of the function? Well, the function is f. So what we're going to do is we're going to rewrite f but we're not going to have any x's. We're going to open up parentheses. So what we're going to do, we're going to drop in w plus 1 in each set of parentheses. When we do that, we square w plus 1, and we have to write it twice. That's what squaring means. We're going to FOIL this out, and then we're going to multiply everything by 3 in that first set of parentheses. Take a look. And in our second set of parentheses, we're going to multiply everything through by -2. And what we're going to do, last step, combine like terms. Take a second and combine the like terms, and let's see what you get. Hopefully you got 3w squared plus 4w minus 3. We're going to talk about something called relation, a mapping of input values, which are x values, onto output values, which are the y values. We're going to show you 3 ways to represent the same relation. We're going to start with an equation. Here's our equation. Y is equal to x squared. So y is equal to x squared. We're going to put in a -2 in for x, and that shows on our table. So when we put in a -2, what do we get out? We get out 4. The next thing we're going to do is we're going to rewrite it, and we're going to put in a -1. What do we get when we plug in -1 into the function? You got it. We got a 1. Let's fill in the rest. There we go. Now, since these are coordinates here, couldn't we graph these points? Absolutely. There we have it. -2 and 4, -1 and 1, 0, 0, 1, 1, and 2, 4. If we were to connect these, voila, we have a quadratic. Next, let's take a look at this. Which of these relations are functions and y? We have x and y listed right here, x values, and over here we have our y values. Do we have an x and a y, x and a y, x and a y, 3, -2? Yes, it is a function. All right, let's take a look at our second one. What do we have? We have a 4 and a -2, 4, -2. We have a 7 and a -1. We have a 4 and a 0. And this is not a function. Does anyone know why it's not a function? Oh, because from Algebra 1, if the x values repeat, we have a 4 here and a 4 here. If the x values repeat, it is not a function. All right, let's take a look at our third example here and see. We have a mapping. These are x values over here, and these are y values. And so what we're going to do is let's put together some coordinates. The 3 goes to -2, so that's 3, -2. And the 5 goes to 1, so that's 5, 1. And wait a minute, there's an arrow going to something else. What does that mean? Oh, 5 is also going to 0. So, any of our x values repeat? Absolutely. Here's a 5 and here is a 5. Is it a function? No, it's not. So a relation is a function if no x values repeat. Hopefully you all remember that from Algebra 1, and if not, great, we just went over it. From our picture here, is this a function? Do we see any repeating x values? We don't. We can do our vertical line test from Algebra 1. We take a vertical line and go through the function. No points line up vertically, so there are no x's that repeat. Graph each relation below by using a table of values. Let's go. We have our tables ready to go. We're going to put in some values. I just picked 0, 2, and -2. So everywhere I see a 0, everywhere I see an X, I'm going to plug in a 0. There we go. We open up our parentheses and put in a 0. We get out -3. There's the point plotted. We open up our parentheses, and this time we put in a 2, and we get out -4. We do it again. We open up our parentheses, we put in a -2, and we get out -2. We're graphing these points, and we could extend a line with arrowheads. There we go. We just graph this first relation. Number 2, since I have the absolute value there, I'm going to try some negatives and some positives. So I have 3 times the absolute value of -2, which is 6. 3 times, y equals 3 times the absolute value of -1, which is 3. One more time, 0, 0, 1, 3, and 2, 6. Here we are, graphing it at the same time. Let's connect the dots. Wonderful absolute value. Okay, so just to do a check for understanding, I would like for you to submit this to your teacher. You're given a function. The first one, the function is x minus 2, quantity squared, plus 1. I'd like for you to find f of -2, f of 0, and f of 2. You can review your notes to see what do you do when you're given a value. Okay, and also submit number 2. And that concludes the lesson from day 1.